My name is Martin Lorenz. I'm the Director of Technology of the WPI. And the presentation today is, when I was preparing the presentation, I was actually not sure how obvious this whole issue of identification and linking actually is. So it was kind of hard for me in the preparation process to determine the spread of information that I should put in this, how explanatory should I be about identifiers, and the technical aspects. So having heard all the presentations today, I'm very much surprised how aware everybody is that identification and precision, accuracy is, and how relevant that is to your material. So there might be slides in that presentation that were created based on the assumption that it is not so obvious. So I'll probably skip over them and keep talking a little bit more about the stuff that that might be relevant here. The agenda of my presentation has basically three main parts. I want to start talking about the mission of the WPI and why we're doing all of that. Then I want to introduce the information system that we are designing, or that we have designed, that we're running inside our organization. And the main part of that presentation should actually be a discussion about data collaboration and data sharing issues. Like what are the observations that we have, and what are the ideas that we want to share with the community, how we can improve certain things for the entire community. So the mission of the WPI is to compile catalog raisonnés and archives that support research in the field of art history. In that, for that mission, we follow an evidence-based approach, saying that all the opinions, all the facts that we publish are basically backed by material from our archive. Because that is basically the main purpose of this institute. Consequently, the design of our information system reflects this mission very clearly by separating into two main components. The base component is a digital archive, which is basically an ISA-GEAD compliant storage and description for archival material. And archival material that we basically have, those are letters, stock books, exhibition, and sales catalogs. On top of that basic module, we have a catalog management module, and this part of the system is managing artwork-centric information, provenance information, publications, exhibitions, and auctions. The data model, very simplistic here, but just to give everyone an idea, what kind of information that we collect, we're basically storing information about different agents, exhibitions, artworks, publications, and auctions. And this entire, the core of this entire data model is an event-based system, meaning that all the facts that we basically record are recorded in sort of events. Like an artwork was sold, an artwork was created, a publication was released, I don't know, an artwork was stolen. Everything that you want, it's basically, you can express everything that you want to record in form of events. And for the archive, the data model is a bit is a bit more simplistic. So we're basically storing resources and media, whereas resources is basically descriptive files about, if you would have a file system on your computer, you could basically put a lot of metadata on your files describing it, like scope and content, summary, and also index this different resource with who is the creator, who are we talking about in this resource, and so on. And eventually, obviously, you want to have media that is attached to these resources. I just went into our system to give you an idea of where we are and what's the scope of the project. And I checked the numbers that we have at the moment, and the system at this point is managing 75,000 artworks, 130,000 exhibitions, 130,000 auctions, 63,000 exhibitions, 265,000 publications, 120,000 resources, and a little more than 12 million media items. That being said, the whole digitization process has actually just begun. So that was basically stuff that was compiled by the Wildenstein Institute like for the last 10, 15 years. And I assume that we're basically an order of magnitude below what will eventually end up in the system in terms of like archiving, volume of the archive. So this depiction, I'm not sure if everybody can read that, but it's not really important that you can read every single word on here. But it basically shows that the catalog entries that we create in the cataloging system, like every entry, every fact that we publish is ideally supposed to link to some type of archival material, either a single scan, a complete publication, or maybe a complete collection that is supposed to allow the audience that will consume our content to follow our train of thought. Like, why do we make this assumption? Like, why do we make this statement? So ideally, we want to back up everything with archival material. So that's the idea. And it will look eventually like something like this. And you have a provenance record that says like this was a sale at the Hotel Drouot in Paris, and you can click this link actually, and then you end up on a page where you have a preview of the of the sales catalog, and then you can ideally like see why we captured that type of information. Same goes for exhibitions. We usually link that to exhibition records, to exhibition catalogs, and you can also jump directly to the page and see where the information is coming from. The overall architecture of the system, I mean, we are living in a basically web service dominated era. So consequently, our system is specifically designed for web interactions. So we have a centralized database system. It's a relational database system that can be accessed via SQL. On top of that is an API system that can be plugged into arbitrary client applications. And in the case of like the WPI, we have two main client applications, and this is the editorial app, which is currently used by our staff for internal operations, to curate the archive, to prepare the catalogs, and so on. And the second part is the public display. So that will be the part that will eventually be available to everyone in the room, or like to the entire community. And we're planning to release a version of the archives public display somewhere late spring, early summer, and the cataloging component, at least for the first project that we want to do, late this year. So those are the things to come. And on top of that, because it's a web-based system, we use an API. You heard about APIs all day long. I'm not sure how many people actually have experience with APIs, but I think there were a couple of explanations that I found pretty convincing, and that should, make everyone understand what this API is. But basically, it would allow any arbitrary client to leverage the information that we have. At the moment, since we're working on the public display, we do not have a public documentation of our API. But as soon as we will release it to the public, then there will be documentations that you can just go to our website, see how it works, capture the information, and then have access to our material. And that's where actually the dilemma starts, or like where I would like to put my finger like on a topic that seems a bit controversial at the moment, or we're not sure how to deal with that. So first of all, why is it important to share information? And I think it has been pointed out between the lines, or very obvious, that expertise and authority and information is distributed across information, and that's good. Like, nobody's supposed to collect all the information. So although we're talking about silos, that's basically a technical way of saying like you're capturing all the stuff like for yourself. I don't necessarily think that's bad, that there are organizations that take care and manage certain data because they have the expertise. The question is like, how can you make that available so that there are no other institutions that say, oh, well, it's very good that you have that data, but I need it for my own purposes. I can't get it, so basically I'll copy it or whatever, or I create my own data, and then it sits in my system. So by this huge digitization efforts that are coming across in recent years, we have unprecedented opportunities to improve the accessibility, to reduce redundancy. I think that's a huge issue for a lot of people, and to complement and combine data from different sources. And I think that's where collaboration comes from. that's basically one slide where I wasn't sure like how obvious that issue actually is, but I tried to find a similar example, a parallel in a different domain that somehow says like why can't we work like that? In the US, you have the social security numbers, and like hospitals, banks, insurance, they usually keep records of yourself, and the identifier that is usually used is the social security number. If you want to buy a car and you don't have enough money to pay cash, you usually ask for a loan, and it's not surprising. Like it will take just a couple of minutes for the dealer to tell you like you're eligible for the loan or not. So how is this working? They basically check your credit report, right? So they say they somehow have the ability to check with the bank, and the bank will tell them, right, okay, so he's eligible or he's not, and that's basically an instant operation, right? So you do not have to do much research to find out if that person is actually eligible for a loan. Another example is if you go to the doctor, right? It would be really bad if you go to the doctor and ask him, like, what is my condition? And he says, well, come back in 2 weeks because I have to compile like all the data, all the files from the different hospitals in order to make a good judgment about your health condition. So what they usually do is they open their computer, they use some client system, they enter your social security number or whatever, and then instantly they have the records. And it's not because they have the records inside their own silos or inside their own system. No, it's because there is a data sharing infrastructure in place that allows to fetch this information in real time from the systems that actually host the information. So like, why can't we do this in the art world? Like, why can't I go to an information system, say, I need information to that art with regards to that artwork or with regards to that artist, and that should work exactly the same way, like very seamlessly. So why isn't that possible? Why don't we see that more often? And that question has different levels. The first is, are there any transportational issues? Like from a technical perspective, is there anything that prevents us from actually communicating the information? And since the invention of the internet and the different protocols that are in place on the internet, there is like everything that we need to transport information from A to B securely and in every different way. So that's no issue. Like that works already. Then if you have basically the connection, what you need is to decide how you transport or like how you exchange information, like the message formats, and even those are pretty good defined. So we heard about triple stores, so they usually use RDF data structures to exchange data. We heard about JSON, that's a pretty good format to exchange information, and then there's also XML, YAML, and all these other things that work seamlessly in all other industries. So that's not an issue either. The problem is actually, or the challenge where we observe some lack of maturity is identification and semantics. How do we identify objects that we want to share information about? And obviously there are identifiers out there. And the question is like, why, like how do we leverage these identifiers? And I just picked this from Katie's, I just saw that slide on your presentation. So I was asked like, why do we do this? And it seems like a lot of people have a very basic question. They seek information about one specific artwork. So like that seems to be a real use case that a lot of people want to do. And the question is, why isn't that working so seamlessly? And there are 3 answers to that. So some informations, they simply do not record, or for some type of objects, for example, artworks, there simply are no publicly available identifiers across the board. The second could be that the system that we want to query simply does not record the identifier that I know or that my system can work with. And the third is that maybe the system records alternative identifiers, which would require somehow complicated mapping procedure to understand like what kind of information can I get out of the system. So if we look at the 2 main objects that we want to share and want to like give access to other people, then we're talking about artists and artworks. And analysis of these two objects or the identification mechanisms for these two objects. We checked out the Wiki Data website, and here's an example of Monet. So if you would go to Wiki Data and enter Monet, you would find a lot of different identifiers for Monet. You have the Luland, you have the Wiki Data ID, you have the ArcID, Arcus ID, and you have in total 118 identifiers for Monet. So basically, you have to make a choice, right? And how do you make that choice? Basically by trying to understand who is using what identifier, and that's already pretty difficult. And you cannot go to your IT personnel saying, please implement an interface to this information system using that identifier. Next week you're going saying, oh, I've seen very valuable information in another information system, but they use a different identifier, so I need to connect to that. How do we do that, right? So that takes time and money, and that's usually, nobody has that available all the time. A more thorough analysis that we did was that we went to Wikipedia and looked at the list of most expensive paintings. And we just checked out the artists that have created these type of paintings. And it turns out that on average, Wikidata lists 96 identifiers per artist in that list. The biggest one is Picasso with 168 identifiers, and the smallest one is Wang Meng with 24. And across the entire group, we found 6 identifiers that you could actually use interchangeably. They basically record information for all, or they encode any of these artists. So, so you have 6 very hard choices, and then you have probably 90 choices that are a little bit more difficult for you. Same goes for artworks, but there is a different observation. So if you want to try to identify artworks, the picture looks a little bit different, and what you can see here is that there are certain artworks, like the Mona Lisa. That painting has actually 27 different identifiers, and that's because I probably wouldn't consider the Mona Lisa an artwork, but more an icon or something that is relevant to a lot more people than just art historians. But when you look even at the list of the 100 most expensive painting, you can see that there are certain blank spots where you don't have identifiers at all. So how would you want to encode them? Like, how would you want to exchange information for those? And so that's basically the two dilemmas that we see for artists. You have a very tough choice, so you have to commit to something. If you want to support or if you want to access everything, then it's expensive and complicated, and well, that's a tough call that you want to support everything. And for artworks, you basically don't have much choice. So what usually happens is that you use proprietary internal identifiers, and those have the problem that they are really difficult to share because nobody knows about them. Like, I don't know what the ID of an artwork is in some proprietary information system at a museum. Like, how would I know that? If there wasn't something like the Kona where you could go and have some search interface and hopefully find the thing that you're looking at and use the ID and then query other information systems, like for proprietary systems, that is not possible. So my question would be, what is the reason why we do not have a federated approach to the identification in the field of art history? So it seems like a lot of people have the same idea that identification is good, it creates precision, it reduces redundancy, and it increases the accuracy of our information. But somehow it seems like we cannot agree that one thing is enough. So there are many options that we have, and that makes it complicated for everyone. So that's maybe a question for the discussion afterwards. Why isn't that possible? And we're basically not the first to have this problem. I'm coming from a background, I was working for SAP, and I was working in supply chain management. There was a pretty similar problem. And there is this GS1 standards organization, and they have basically defined standards for encoding identifiers, for sharing information, and for the use. So the global trade item number, I think everybody, when you buy a product and you turn it around, you usually see the barcode on the back. So that's basically on every product, and that also exists for services and so on. So it's uniquely identifier that is basically accepted by everyone that is producing something and that wants to sell something. And on top of that, there have been protocols and information systems that they invented to actually support the seamless interchange of information that is standardized, controlled, efficient, scalable. So I don't think that this is a blueprint that we should look at because it's really complicated and maybe a burden if we would try to implement this one by one. But it might be a good how do you say that? It might be a good example, right? So there are blueprints out there that we could look at, see how they did it, and like, why not do that? Like, that could be definitely an option. All right, thank you very much.